This is part 6 of the series Reasoning and Proof. In the last part, we worked through some basic problems in justification of steps to solve simple algebraic equations. And we're going to take that one step further in this part, and we're going to formalize the concept into the idea of a formal logical proof. So to start off, we're going to give a definition of a proof. This would be one working definition: a logical argument that uses deductive reasoning to show a statement is true. Now, the implication here is that we start with some premise, some idea that we're trying to prove, and we develop this logical argument to show that that idea is true. Now, generally speaking, we would call that premise the hypothesis, but it can be a conjecture, it can be pretty much anything you want to call it, but that is going to be the information that we're starting with, and what we're trying to prove is the final result. Now, the way we do this, there's several different forms of proof that we're going to look at. The two most prominent ones are two-column proof and paragraph proof. Now, a two-column proof is the more formal of the two methods, and many people find it a much more straightforward way to organize proofs. So we're going to start with a two-column proof. So let's look at the definition of a two-column proof. And it's simply a structured form of a proof arranged in columns with logical statements on the left and reasons or justifications for those statements given on the right. Now, we start with a given piece of information and what is to be proved. So that is our hypothesis or our premise, and what our final result's going to be. Now, just to exemplify this idea, let's take a fairly simple example and let's work through it to form a good base for our work moving forward. One of the keys to any problem-solving situation is understanding what it is that you're supposed to be solving. So the first thing we want to do is we want to understand what information we're being given and what it is we're supposed to do with that information. So in proofs, generally, you're going to want to investigate the picture of whatever it is you're given. If you're not given a picture and you're given a textual description, depending on whether or not you're a visual person, you're going to want to draw a picture. Even if you're not visual, the visuals do help in giving you a mechanism for documenting the work as you move forward. And one thing you're going to find is that documentation as you work through these problems is going to be crucial. For those of you who have developed a habit of doing things in your head, mostly because the work has either been fairly trivial or you perceive them to be simple, I'm hoping that through this process you're going to see the value in writing down your steps and working through your thought processes and putting them down to help you follow a much more complex set of situations. So let's take a look at this situation. First thing we have is we clearly have three angles here. We have angle 1, angle 2, and angle 3. And we're told that the measure of angle 1 equals the measure of angle 3, and that's given to us also pictorially with these little arcs in here telling us that these two angles are the same angle. And we need to prove that the measure of angle DBC, which is this angle in here, is equal in measure to angle EBA. So this big angle in here. Now that we understand what it is that we're supposed to do and where we're coming from, we know that this angle is equal to this, and we're looking for the measure of this angle equal to the measure of that angle. We have to try and determine some sort of plan. It's always a good idea to have some sort of path through this mess that will help guide you as you get into the details of the steps. Now, one of the big mistakes people make in proof is they get stumped and say to themselves, I don't know the statements. I don't know what to put over here. And the key to doing proofs is think of it as a person working on a car. The person working on a car knows about all the tools they have to work with. They know what the tools can do, and they know how to apply those tools. And so with the knowledge of the tools, our analogy in this case is our reasons. The tools that we have are our definitions, our postulates. Later on, we're going to talk about something called theorems, but the basic rules and facts that we have to work with. And once we know that what those tools are, it's much easier to build these statements. In fact, proofs are driven by the right side, not by the left. The left side falls from knowing what tools we have to work with and where we're supposed to be going, and these statements just kind of naturally develop. So let's take a look at this. We look up here and we can see that we have to show that this big angle is congruent to this big angle. Well, the common element here is that angle 2 is shared by angle ABE and DBC. Well, if that angle is shared by both, then we have some common pattern here. We can look at this and we know that angle ABE is made up of angle 2 and angle 1. Angle DBC is made up of angle 2 and angle 3. So that common element, angle 2, is sitting in there. So I should be able to say, well, if angle ABE is made up of 1 and 2, and DBC is made up of 3 and 2, and I know that angle 1 and angle 3 are the same, I might be able to do some sort of a substitution to replace the 3 with a 1 or the 1 with a 3, and I will have angle 1 equals angle 2 for both of these angle measures. So that's a general idea for what I'm going to try and accomplish here. And with proofs, a lot of times you may have to do 3 or 4 trials through the proof before you get it right. Don't think that working through a proof it should be automatic and quick. A lot of these proofs take time. So be patient, work through it, and most of all, be prepared to make a mistake and be willing to start over again and redo it if you think that you're being led down a blind alley. So let's start off. I usually like to start with my givens. Now, it's not necessary, but I like to do that to get it out of the way and put my information down right up front. So I'm going to start out by saying the measure of angle 1 equals the measure of angle 3, and that's my given information. So I put my statement and my reason. Again, I knew that I was given this information, so this statement is driven by that statement. Now, my pattern, the path I wanted to take through this is I wanted to say, well, since angle ABE is made up of 1 and 2, and DBC is made up of 3 and 2, that somehow I can merge those together. Well, I need to make those statements. But before I make that statement, what tells me that angle ABE is equal to angle 1 plus angle 2? Well, if you remember, that was the angle addition postulate, one of our reasons. So because I knew the angle addition postulate, that angle 1 plus angle 2 equals the measure of angle ABE, that's what allows me to make that statement. Also, I know that the measure of angle 2 plus the measure of angle 3 equals the measure of DBC. Again, angle addition postulate. So that's the statement I'm going to write next. And there we have it. The measure of angle ABE equals the measure of angle 1 plus the measure of angle 2. And I combine two statements in one because it's the same reason. The measure of angle DBC equals the measure of angle 2 plus the measure of angle 3. 2 plus 3. Notice the use of my symbolism. The measure of angle ABE, measure of angle 1, measure of angle 2. If I'm using equalities in addition, I can't use the angle itself. I have to use an attribute of the angle, which is its measure. So that gives me my first statement. Now, in order to move forward with this, I said that I wanted to merge these two together. Well, I have a common element here, angle 2, in both of these expressions. Well, I know that angle 1 is the same as angle 3. So if I change this angle 1 here to an angle 3, then this is going to be equal to that. I'm going to have a 2 plus 3 and a 2 plus 3, which would mean that this angle and this angle would be equal. So I'm going to do that, and the reason that I can make that substitution, hopefully that was your key, is the substitution property of equality. I'm going to substitute the measure of angle 3 for the measure of angle 1 right here. I could have substituted the measure of angle 1 in here. It really doesn't matter. It's pure style. But that's what I'm going to do next. So now we've changed this statement to be this statement. I've substituted angle 3 for angle 1. So angle 3 replaced that angle 1 right there. And now ABE is angle 3 plus angle 2. And now we have DBC is angle 2 plus angle 3. Well, this should be a fairly clear pattern to you. If you remember our law of syllogism and our transitive property of equality, if A equals B and B equals C, then A equals C. Do you see that? 2 plus 3 and 2 plus 3. These are exactly the same. It doesn't matter that these are reversed, because by the commutative property, addition is commutative. So it doesn't matter which order these two are added, they're still going to equal the same value. So this angle plus this equals the same angle plus itself. Now, since I know that by the transitive property, this angle is equal to this angle, I can make that statement. And so I wrote the measure of angle DBC equals ABE. Because again, through the transitive property, if A equals B and B equals C, then A equals C. A equals C. So hopefully you can see that. Again, over here, these reasons drove these statements. Because I knew what I had to work with, I could see their use in the picture and in the given information. Now, this will come with time, and the key to proof is practice. The more you use these reasons, the more you use these definitions, postulates, properties, and all the information that you're given, the easier it'll be to recall what those tools are. Consider, if you will, how easy it is for you to use, say, your cell phone. You probably don't even think about what you're doing as you do it, because it's almost become a part of you because you use it so much. Well, the same thing can be true. I know it's going to sound silly, but the same thing can be true of the stuff we're talking about here. The more you use it, the easier it's going to be to use. And the big obstacle to get over using your cell phone is fun. This stuff, not so much at the first, but you'll be surprised that it can be actually an enjoyable process once you actually learn how to do it and you become good at it. People actually end up enjoying working through proofs. The problem is working through that initial learning curve and disciplining yourself to practice and learn these reasons and definitions and practice working through the proofs. We'll go ahead and do that in the next video. So I will talk to you in the next part.